Okay, so this is the second lecture of integument, effects of environment on the skin. My man's like, yo, effects of environment on the skin. Effects of environment on the skin. I'm going to go through this quite quickly, inshallah. So, just quick reminder, integument means the skin, hair and nails. So additional information on from the last lecture is the epidermis, and the dermis can be referred as the cutis, and the subcutis is also known as the hypodermis. Cool? Okay, so we'll go through this part quite quickly because it is minor, this information is minor. So importance of keratin. Well, this is important. Keratin is important in protection and adaptation. Okay, so this is the one important point I want you to remember. Keratin is important in protection and adaptation. The rest you should know anyway. Daughter cells move distally or upwards through the epidermis, while differentiating into mature keratinocytes. Keratinocytes make lots of tough and waterproof protein called keratin. Simple? Cool. The top of the epidermis, or the stratum corneum, is made of cornified keratinocytes that lose their nucleus and continue to move upwards distally. So, as you remember from the last lecture, they were anucleated cells at the top of the stratum corneum, which are full of keratin. These are the cornified keratinocytes that we're talking about here. The stratum corneum is referred to as being keratinized, which is full of keratin, meaning full of keratin. The stratum corneum cells flake off and are constantly being replaced, and nails are made of keratinocytes which are packed full of keratin. All simple enough. We'll carry on. The skin is a vital organ. So extensive epidermal, or both epidermal and dermal damage, such as a severe burn or a drug reaction, can cause death. Yeah, this could be due to dehydration, shock, infection, heat loss and hypothermia, or sometimes hyperthermia due to impaired thermal regulation. And finally, there's some other reasons which may cause a death due to epidermal or dermal damage, which, for example, such as protein loss, electrolyte imbalance, high output, cardiac failure, or renal failure. So we'll go through them quickly. So extensive epidermal and dermal damage can cause death. And how could it cause death? Through dehydration and shock, infection, heat loss and hypothermia, or sometimes hyperthermia, and other reasons such as protein loss, electrolyte imbalance, high output, cardiac failure, or renal failure. Okay, so now carry on to this thing called toxic epidermal necrolysis. Toxic epidermal necrolysis. It's a rare drug reaction, and it's where there's a detachment of the epidermis, which is often fatal. I'm going to show you a picture of it now on the laptop. You can see that there is toxic epidermal necrolysis, a rare drug reaction, and it's where the detachment of it's a detachment of the epidermis, which is from the skin, which is often fatal. So why is our skin so vital? So the skin protects us from a wide range of insults. These insults include irradiation and UV light, physical trauma such as burns, friction and pressure, irritants, allergens, microbes, or ectoparasites. Okay. Just one thing to bear in mind as we move on. These are some pictures of epidermis, dermis, subcutis. As you can see, these may be tested in the exam. There's my epidermis, dermis, subcutis, as I believe. Let's carry on. So we then go on to the features of the skin that protect us against stress. If the camera focuses, there we are. Features of the skin that protects us against stress. My man's like, yo. Anyway, there's stress. So there's a number of stresses, and there's a number of ways the skin protects us from these stresses. So first stress, for example, drying out the skin. How the skin protects us is there is a waterproof epidermis and oil from sebaceous or sebacous gland. Another stress is friction and impact, and how the skin protects us through a number of ways: through thick regenerating epidermis, through our nails, through our basement membrane, which is anchoring sorry, that's bad. You can see anchoring, basement membrane, anchoring the epidermis to the dermis with wavy borders against which helps against shear forces. So these wavy borders help against shear forces. And also finally there's collagen fibers in the dermis which are strong and running in all directions. Cool? So thick regenerating epidermis. Okay, so we had some technical difficulties, but now we're back. Carrying to friction, so stress is friction impact, how this can protect us, thick regenerating epidermis, nails, basement membrane anchoring epidermis to dermis with wavy borders against shear forces, and collagen fibers in dermis which are strong and running in all directions. Another stress is heat, and how this can protect us is through sweating and vasodilation. Another stress, cold, how the skin protects us, vasoconstriction, subcutaneous fat, hair erecting, which is goose pimples, and an adaptable blood supply. So as we mentioned in the last lecture about the arteriovenous anastomoses, AVAs, this is another way that that we can be protected from the cold via shifting of blood from certain areas. Cool. So another stress is burns and injury, how the skin protects us through thick regenerating epidermis. In addition, there's radiation and the sun, even though that looks like fun. Trust me, this isn't fun, this is sun. I wish this was fun. Anyway, the radiation and the sun and how the skin protects us is through thick epidermis and melanin. And we'll come on to melanin furthermore. Another stress is infection, and how we are protected from infection is Langerhans cells, which are antigen-presenting cells, and other immune cells. So we move on. There are adaptations of the skin which limit negative effects of the environment. These adaptations can be fast or slow. Example, vasodilation and sweating in heat, or vasoconstriction in cold. These are fast adaptations. They happen day to day, minute to minute. Easy peasy. There's also something called hyperkeratosis. This is the thickening of the stratum corneum with rubbing or pressure. For example, on my feet, which is a slow adaptation. Do you want me to show you? I'll leave that for later. Anyway, another adaptation is melanocytes. These melanocytes cause tanning after UV exposure, as these melanocytes will increase in production of melanin in order to protect DNA, as the melanin sits over stem cell DNA. And this is a slow adaptation, and there's more information on this in the lecture as we move on to the next page. Okay, so UV protection by epidermal melanin. So the colour of human skin is due to mainly melanin in dark skin and hemoglobin in light skin. There's lots of genetic variation in the amount of melanin, because there's over 12 genes known in the production of melanin. Each gene will probably cause a different amount of melanin to be created. Melanin protects against DNA damage and therefore skin cancer. So melanin protects against DNA damage and therefore skin cancer, especially in dark skin. That's especially in dark skin. Skin cancer in dark people is 8 to 10% of the incidence of white people. Subhanallah. Okay, and now we'll go on to melanin. Melanin is made by melanocytes. Melanocytes are often in the stratum basale. This is important. Melanocytes are often in the stratum basale, or in the basal layer of the epidermis. Melanocytes have dendrites that feed melanin to keratinocytes, and we see that in the picture. These are dendrites here, yeah. And these dendrites feed melanin. These dendrites on the melanocytes feed melanin to keratinocytes, and you have to beware. There's a common mistake which. So as I was saying, there's a common mistake that draws melanocyte dendrites going to the upper layers of the epidermis, but dendrites actually only go up a very few layers. Cool. Finally, melanin that enters keratinocytes sits on top of the nucleus to protect DNA. And as we mentioned in the page before, it protects the DNA of the stem cells in the stratum basale. Cool.